Here we'll solve a rational inequality. X over x minus 2 is greater than negative 3 over x plus 2. When you have a rational equality, we want to begin by finding the least common denominator, or LCD. Our LCD will depend on the denominators we have. Our first denominator is a binomial, x minus 2. Our other denominator is another binomial, x plus 2. If you have two different binomials, both binomials must appear in the LCD. Therefore, our LCD will be x plus 2 times x minus 2. Before we go any further, let's also find the restricted values for this rational inequality. To find the restricted values, we'll set our LCD not equal to 0. This is because of our domain rules for fractions. We are not allowed to divide by 0, therefore our LCD may not be 0. We'll say x plus 2 times x minus 2 is not equal to 0. We'll split this into pieces and we'll set each piece not equal to 0. Now that we have it in pieces, we'll move the 2's from the left to the right. Move the positive 2 over and also move the negative 2 over. When you move the positive 2 over, we'll get x is not equal to negative 2, and we'll move the negative 2 over, and we'll get x is not equal to 2. We now have the restricted values for this inequality. Bear in mind, when it comes time for us to draw our number line, these restricted values will both end up as open circles. With that in mind, we're going to modify our fractions in this rational inequality to give us the LCD. We want our LCD to be x plus 2 times x minus 2. This means our first fraction, which has x minus 2, will need x plus 2. Our other fraction, which has x plus 2, will need x minus 2. Therefore, our first fraction on the left will be x over x minus 2, but we'll multiply x plus 2 on top and bottom. Also making sure that we place the parentheses around the x minus 2. We'll say this is going to be greater than negative 3 on top, and then x plus 2 on the bottom, but we'll multiply it on the top and bottom by x minus 2, which is what we needed for our second fraction. Now that we've modified our fractions, we're going to take the fraction from the right side and move it to the left and change the sign on the numerator. This will give us 0 on the right and 2 fractions on the left. If we make that move, we are going to take the entire fraction off the right, move it to the left, and change the negative 3 to positive 3. This will give us x times x plus 2 over x minus 2x plus 2 on the left. And now we're going to put plus 3 times x minus 2 over x plus 2 times x minus 2. And we'll say this is greater than 0. This is now our rational inequality. It's much more manageable now that we have a 0 on the right. However, we now need to combine those fractions, which we'll do on the next slide. Now that we have both of our terms on the left side, we're going to distribute the x to both terms of the x plus 2, and we'll distribute the positive 3 to both terms of the x minus 2. The first x times x gives x squared, and then that x times 2 gives plus 2x. Then the 3 times the x, which I've outlined in orange, will give plus 3x, and 3 times negative 2 gives negative 6. This will still be over x minus 2 times x plus 2, and this will still be greater than 0. Notice that we are not going to simplify the denominator at all. We're going to leave it the way it is. Now we'll combine the like terms in the numerator. 2x plus 3x will give us 5x. Now we're going to try to factor the top so we can have a factored form just like we do on the bottom. We're going to try to split that x squared plus 5x minus 6 into two pieces. If we split that into pieces, we're going to look to the final term, the minus 6, and think of two numbers that multiply to negative 6. If we try negative 6 and 1 and add them together, this will give us negative 5. That's the right number, but not the right sign, because we still want positive 5x. Therefore, we should use positive 6 and negative 1. That will give us positive 5, and that's a match. Therefore, we rewrite this fraction as x plus 6, x minus 1, over x minus 2, x plus 2. And we'll say this is still greater than 0. Now that we've factored the top, let's solve it by setting it equal to 0. We'll say x plus 6 times x minus 1 equals 0. If we solve the first piece, we'll have x plus 6 is equal to 0. Therefore, x is equal to negative 6. That will be our first 0. And then we'll say x minus 1 is equal to 0. And then move the 1 over, and then get x is equal to 1. These will be our zeros of this rational inequality. So on this slide we found the zeros, and on the previous slide we found the restricted values. Now we'll put that information together on the next slide. Here I've written the factored form of our inequality. X plus 6 times x minus 1 over x minus 2 times x plus 2 is greater than 0. I've also written the zeros we found on the previous slide and the restricted values we found on the first slide. We'll mark those on the number line now. Negative 6, 1, 2, and negative 2. We'll also place the infinities on the left and the right. We'll also make a note of our condition. The condition we have is that we want it greater than 0, but strictly greater than 0. Therefore, our circles will be open, and we are looking for positive answers. Based on what I've marked, we'll put open circles at each position, and this will split the number line into 5 regions, A, B, C, D, and E. We'll begin with region A, and now we'll pick an x that's in region A. I'll select x equals negative 7. Every position where we have an x in this inequality, we will replace it with negative 7. Now we'll simplify our answer, but let's not worry too much about the numbers. We really only care about the signs because the only condition we have is that our answer at the end must be positive. So we'll take negative 7 plus 6. That gives negative 1, which is negative. Negative 7 minus 1 is negative 8, also negative. Negative 7 minus 2 is negative 9, also negative. And the negative 7 plus 2 is negative 5, also negative. Therefore, we have a quadruple negative. If you have an even number of negatives, that means our final answer will return positive. Therefore, region A will be positive, and since this matches the positive condition, region A will be part of our answer. Next, we go to region B and pick an x between negative 6 and negative 2. I will choose x equals negative 3, and now we will redo the calculation with an x of negative 3. We'll take negative 3 plus 6 first, that's positive 3, which is a positive answer. Negative 3 minus 1 gives us negative 4, which is a negative answer. Negative 3 minus 2 is negative 5, a negative answer. And negative 3 plus 2 is negative 1, which is negative. We now have a triple negative, and a triple negative is an odd number of negatives, which means our final answer will be negative. That means region B is negative, but that does not match the positive condition we want, so region B will not be part of the answer. Now we move to region C and pick something in between negative 2 and 1. We'll use x equals 0 here. This will give us 6 times negative 1 on top over negative 2 times positive 2. If we take 6 times negative 1, we'll get a negative, and then negative 2 times 2 will give us negative 4, also negative. But here we have a double negative, and a double negative will return a positive answer. Therefore, region C is positive, and that matches the condition, so region C will be part of the answer. Next, we move on to region D. Let's pick an x that's between 1 and 2. There aren't really any easy numbers to use here, so I will use 1.5. We'll now rerun this calculation, but replace all of our x's with 1.5. Now that we've placed the 1.5, we'll do the math. 1.5 plus 6 gives 7.5, that's positive. 1.5 minus 1 gives just 0.5, but that's positive. 1.5 minus 2 gives negative 1.5, that's negative. And then 1.5 plus 2 gives positive. We have a single negative, and that single negative means our answer will return negative. Region D will be negative, and that does not match the condition, so we cross that out. Finally, we move to region E. Region E will have an x greater than 2, so we'll say x equals 3, and now once again, we will replace all of our x's with 3. We do the math and say 3 plus 6 gives 9, that's positive. 3 minus 1 gives 2, also positive. 3 minus 2 is positive 1, that's positive. And 3 plus 2 is 5, also positive. Here we have all positive, therefore our answer returns positive. Therefore region E will go from 2 to infinity, it is positive, and that matches the condition, so region E will be part of our answer. So our final solution for this inequality will be region A, union C, union E. We will write negative infinity to negative 6, union, negative 2 to 1, union, 2 to infinity for region E. This is how we get all three of our solution regions, and this will be the solution of this rational inequality. So the process is fairly similar to our polynomial inequalities, except for that we must use restricted values and zeros, not just the zeros. Thank you for watching. We'll see you again soon.